I have uploaded video on functional groups and isomerism, all the basic concepts on organic chemistry in one of my other video. Now we are moving to reactions given in class 10, um, carbon and its compounds. Yeah. So over here, the first reaction, combustion. We know combustion, there are two different types of combustions are there: complete and incomplete combustion. And the complete combustion means the reaction takes place with sufficient oxygen. And incomplete combustion, when the insufficient oxygen, right? So which leads to, if it is a complete combustion, which leads to carbon dioxide and water. If it's in a insufficient oxygen, in the sense, which leads to carbon monoxide and water. So balancing alone, we need to keep in mind over here carbon, with when it burns in oxygen, you get carbon dioxide, heat energy, and light energy evolves, that is there. But where we need to balance over here, like in methane and all, if you see, check the number of carbon atoms in the reactant side. Initially, check the number of carbon and hydrogen in the reactant side and balance it in the product side. Later, count the number of oxygen in the product side and balance it in oxygen. That will help you a lot. So number of carbon atom only one, so make it, yeah, it's already one. And there are 4 hydrogens, so make this water 2 moles. So 4 hydrogens are there. Now check the number of oxygen here. There are the 2 oxygen over here and plus 2, 4 oxygen. So which means balance it in the reactant side, 2 moles of O2. That's all. It is balanced, right? So whatever alkane they give, you can balance it in the same way. And also you have to keep this in mind. What is it? If it is an alcohol, there is oxygen over here, right? Suppose if you are balancing, there are 2 carbon atoms, so make this carbon dioxide 2 more. And there are 6 hydrogen in the alcohol, so make it 3 moles of water. So that 3 into 2, 6 hydrogen. And now count the number of oxygen over here. There are 4 oxygen in carbon dioxide, and in water 3 oxygen. So totally 7 oxygen. So now you should not forget this oxygen. So 1 over here, and 3 more only you have to balance here. So which means 3 O2. I mean 6 more oxygen, so 3 O2. So this becomes 6, 6 plus 1, 7. So reactant side also 7 oxygen. It is balanced, right? Yes. So similar way, if it is insufficient also, I mean in the presence of insufficient oxygen also, you have to balance in the same way, right? Let me show one equation. So methane on combustion, incomplete combustion, which leads to carbon monoxide and water. So now we are going to balance 1 carbon, 1 carbon, 4 hydrogen, make this into 4 hydrogen. Now count the oxygen in the product side. There are 3 oxygen, right? So 3 oxygen, now we have to put 1.5 O2. Instead, what we need to do, make this methane into 2 moles. This into 2 mole. That means the carbon monoxide 2 mole. So what happens here? Number of hydrogen, 8 hydrogens, right? So 4 mole of water molecule, which means 4 plus 2, 6 oxygen, right? So make this into 3 O2. So this is the best method, right? Okay. And next to combustion, we have oxidation. So in both the equations, oxygen only involves, but over here it is combustion, but over there it is oxidation. So for oxidation, we need oxidizing agents: alkaline potassium permanganate or acidified potassium dichromate. Potassium permanganate, a purple color solution, right? And potassium dichromate, orange color solution. So these acts as an oxidizing agent over here. So one of these you can use it as oxidizing agent. So alcohol oxidized to acid. Actually, alcohol oxidized to aldehyde, aldehyde oxidized to acid, but they didn't show that step over here. Okay, this leads to CH3, CHO, an aldehyde to acid, right? So, but over here, what is it? They left this intermediate and straight away they've given, but that's fine. So from whatever alcohol, if it's propanol, we get propanoic acid, ethanol, ethanoic acid, methanol, methanoic acid, right? So that you should keep in mind. And then addition reaction. Addition reaction over here they've given in any alkene. So alkene, in the sense there is a double bond over here. It can be any alkene. So in alkene, when you add hydrogen in the presence of nickel catalyst, and we have like 200 degrees Celsius temperature, the reaction will happen. So you have to take it as H2, H bond H, keep like this. So one H binds with one of the carbon atom, the other H binds with other carbon atom. So what is it? It becomes an alkane. Okay, suppose think of this is ethene. If all the R group over here, if I put hydrogen, so it is ethene. Now what is it? The compound is ethane, right? You get alkane, right? Whatever it is, the alkene leads to alkane by adding hydrogen, right? Okay, next, substitution reaction. In substitution reaction over here, a methane reacts with chlorine. This will happen only in the presence of sunlight or in the presence of UV light. So the chlorine displaces the hydrogen from methane, so that you get methyl chloride and HCl, chloromethane, IUPAC name, chloromethane and HCl. Actually this reaction won't stop here, it's a continuous reaction till it removes all the hydrogen. The reaction will happen, which leads to carbon tetrachloride, right? So over here they've given only one step, so very easy to learn, right? Okay. So substitution, in a sense, what is it? Substituting the hydrogen with chlorine, right? Because chlorine displaces the hydrogen, right? Okay. So now, when it comes to properties of alcohol, alcohol behaves as acid. Suppose in HCl, if you add Na, what will happen? So it becomes NaCl, and the hydrogen evolves, right? Similar way, even in alcohol, when you leave a piece of sodium in alcohol, it displaces the hydrogen, so you get sodium ethoxide, just hydrogen displaced by Na, but it liberates hydrogen. Hydrogen is what? A diatomic molecule, H2. So that is the reason we use 2 moles of Na. We need 2 Na to displace 2 hydrogen. But this has only 1 hydrogen. So we made this also 2 moles of alcohol. Okay. So 2 moles of sodium ethoxide, which liberates 1 molecule of hydrogen. Right. Hope you understand. And next one. What is it? Over here, from alcohol, how to prepare unsaturated hydrocarbon. What is this actually? It's a dehydration. What is that? Removing water molecule. Think of, this is ethanol, right? This is ethanol. That is what they have showed here. So think of one hydroxyl group from this carbon atom, and hydrogen from this carbon atom goes as water molecule. Okay, and carbon's valency, there are 4 electrons in the outermost shell, right? To compensate that, I mean to satisfy the valency, we have a double bond here. So that's how ethanol becomes ethene, right? In the presence of hot concentrated H2SO4. Why we are using this sulfuric acid, concentrated sulfuric acid? Because it's a desiccating agent, dehydrating agent, which absorbs moistness. Okay, that is why we are using sulfuric acid, concentrated sulfuric acid, to remove water molecule. Let's see properties of ethanoic acid also. So this over here, it's a very good and important reaction, esterification reaction. So over here, how you get ester? Just keep in mind, an acid reacts with alcohol. Acid reacts with alcohol, which leads to ester plus water, right? So acid is over here ethanoic acid, organic acid, alcohol, ethanol. So just you have to listen here. What is it? The OH from the acid and the hydrogen from the alcohol will go as water. So over here, what is there? CH3CO. That CH3CO we are writing here. Okay. So CH3, C double bond O. Or you just write CO also. You can write COO, CH2, CH3 also. Okay. So what is that next? This oxygen binds with the carbon atom. So this oxygen we are writing here. Oxygen. So that is why we put C double bond O here, to show the oxygen binds with the carbon atom. Okay. Otherwise this is also fine. Okay, so oxygen binds with the carbon atom. What is next to oxygen? CH2. Next to CH2, CH3. Okay, so as it is, you are writing over here, right? Whatever acid, whatever alcohol they give, just whatever given over there, remove the water molecule and write it. But while writing the formula, write the acid part first and write the alcohol part next. But while naming it, you have to name it as ethyl. Over here both are eth, so ethyl ethanoate. But when it is some other alcohol, methanol, in the sense, you have to say methanol first, methyl ethanoate. Okay, while naming it, we need to keep in mind. Okay, so this is what esterification also elaborately I have showed in my one of my other video. Over here, as we discussed here, once you get ester, so when you get ester, it liberated water molecule. By adding water molecule, that's what hydrolysis happen. By adding water, lysis, you're breaking the ester into acid and alcohol, right? That will happen even by adding alkali too. That is why they have showed NaOH here. By adding water itself, this will happen. However, by adding NaOH, what is happening? This breaks into acid and alcohol, right? So you get whatever, so what we use there, ethanoic acid and ethanol. So by on hydrolysis, we get same alcohol and acid. Right? Okay, next reaction with base. Yeah, was ethanoic acid is an acid. That means it can react with the base. So by adding sodium hydroxide, what will happen? Acid plus base, what is it? Salt plus water. So same thing, the water molecule will escape over here. So which means CH3COONA. What is it? Sodium ethanoate, sodium acetate, right? Acetic acid comes from ethanoic acid, means acetic acid, right? So sodium acetate, or we say sodium ethanoate, right? Okay, so same thing they've given. How carbonates, any carbonates in acid, in any acid, whether it is a strong acid or weak acid, you get carbon dioxide, water, you get a salt, then carbon dioxide liberates, so you get brisk effervescence by adding acid on carbonate, right? Maybe you all might have done this in baking soda, you have added vinegar, right? So same, like by adding, so acetic acid is vinegar, right? By adding on carbonate salt, what will happen? You get salt, carbon dioxide, water. That's what they've asked here, right? And they've given reactions too. Over here, what is the salt given here? Ethanoic acid with sodium carbonate. What do you get here? Sodium ethanoate, sodium acetate plus carbon dioxide and water, right? Carbon dioxide evolves even with sodium bicarbonate. Same reaction with baking soda. Sodium bicarbonate is baking soda. So with baking soda in acetic acid, same, this is what that reaction is, right? So what is it? Just sodium displaces the hydrogen, right? And what happens here? The carbonate, right, from this CO2 evolves, and one of the oxygen binds with these two hydrogen, which forms water, right? So the salt, carbon dioxide and water, right? Okay, so hope you understood all the reactions. If you have any questions, please clarify it immediately. Okay, so let's see with another video. Bye bye.